This is Project Lumin Lamp. It is a night lamp using a dual fifth circuit and a coil, a swappable coil, so you can swap and replace those coils. I'm releasing this project to the public domain. It's open source project. You can check out hackster.io. If you would like to build it, you will need a basic understanding of electronics and how transistors works and how to assemble PCBs and solder. So there is unfortunately no support on helping you build this, but if you are experienced in electronics and would like to replicate this project, please check at the link in the description, and the page is located on hackster.io. You'll find all the information to build this night lamp or this project Lumin Lamp. You'll have the 3D files, the PCB, all the list of components, and the frame. You'll have to build or wind your own coil. So on my channel, I've shown how to wind the Cartesius coil, but this coil is a different coil. So I'm releasing this coil here into the public domain, so it can't be patented and people can experiment with this. This is called the fusion coil. It's a sort of Tesla coil, pancake coil, but just wound in weaving around this spider web coil frame. Yeah, and I'll show you how to do the build and assemble everything. Enjoy. So once you've printed out your PCB from your preferred manufacturer, the Gerber files are located on hackster.io, link in the below description. So this is what the assembled PCB will look like. Essentially, it's just a dual fifth, just a standard dual fifth circuit. And all the components are listed in the hackster.io webpage, so you can have a look at all the components and see if you can, if you're interested to build and replicate this, then you should have all the components available. So this is what the PCB looks like. And you'll also need a 3D printer to print the base of the lamp. This location here is in case you decide that you would like to have a 9-volt battery. So you can actually just fit it right in here. So you can actually make it portable if you want. There's also the option to use a wall adapter using a micro USB. So this will go, I'll just remove this for now, but this will go right at the back, and I'll assemble it in a minute. Then those are the feet of the night lamp, and those are like washers, plastic washers for holding the ceramic fitting on the print, on the base. So at the minute, this is only for UK, so, or Europe. This is a bayonet fitting. The US friends will have to wait for me to release a new base, and the fitting will look like this for the US. This is in Europe, this is called an E27. But I've been reading that E27 and E26 are interchangeable. I just need to put the holes on the base like this. This will be the base for the US So in US they use E26 fittings. So this E27 will work for an E26 light bulb, according to my research. So this is for the US. I'll start with the PCB, fitting the PCB. Also, on top of the PCB, there is this cover here. It's really just a cover to protect the components and for safety as well, so people don't put their fingers in there, what have you. But if you're using this, so if you're using this for just a night lamp stand, you probably want to put this cover just for safety. But if you're using this for testing, really, you probably don't need this. I'll show you what my testing setup looks like real quick. So here you can see that for me, I've actually got just 3 wires coming out. It looks a bit of a mess, but it will be clearer when we assemble the actual Lumin lamp. So this is basically what my prototype or experimenting setup looks like. I've got 3 wires coming out, and I can plug in all sorts of coils. I can swap this flat coil with different other coils. But anyway, we'll get back to the build. Okay, so we'll start with just assembling this PCB. For this assembling, I'll be putting this cover just to show you how it fits. So this screw is M3 screw. Now, if you want to assemble this lamp, this Lumin lamp, you'll probably be better off just buying a kit like this. They're called M3 stainless steel pan head. So you need the pan head version, and they are M3. So in Europe, this is 3mm diameter, and then we've got different sizes, and you'll probably be using a lot of sizes, in fact. So yeah, this is a nifty little kit you can find on your main online retailer shop. So right now I'm just fitting this M3 screw in here. This is really just so I can attach this bracket. The bracket comes here. All right. Now it does look like it's a little bit too long, so I'm just going to remove that one. Yeah, and then just that bracket, which goes on the side here. Okay, perfect. And then just a little nut to tie it up. Okay, so I've got now this fitting here. It's solid. Okay. So so what I'll need to do is just fit this fitting on top like this. Right. And we still have a couple of capacitors coming out. So you'll need to be careful not to fiddle with them. One capacitor is for the input battery, just to smooth in case you are putting the power from a wall adapter, just to smooth the frequency from the wall adapter. And the other one is for the actual load, which is the output, which is this one here. So if you do go ahead and print your PCB, you have the markings on the PCB here. And so you've got your input minus plus. Now, there's no actual safety diode for this input, so you'll need to make sure that you put your positive power on the right side here, as indicated with this symbol here, and your negative input on that left side. You've got to make sure You don't reverse the connections. If you do, you'll probably damage some of the components here. So again, follow the markings. Now the channel A and channel B, I've really added those because I've done some work on the ABHA coil, and essentially it's just quite the same idea, where channel A is really the first wire, so the first wire of start and then end, and then the channel B is just the second wire, start and end. And as you can see on the trace here, the start of channel B and the end of channel A are connected together. So there's a trace here that connects the two together. So for your coil, you'll need a coil that has a center tap or free wires. So you want to have the middle center tap. I'll show you an example, in fact. So this is a new process that I've come up with. Again, I'm releasing this information to the public domain, so none of it can be patented, and everybody can actually do some research. But this is actually a Nikola Tesla bifilar pancake coil, but it's weaved actually. I even had to print a small threading tool to weave this, and I'll make another video on how to wind this coil, but for now it's just to show you. So this coil has 4 wires, or 4 ends if you like, but it really has 2 wires. So it has a gold and a red, and the start starts here and then the end finishes here. So we do have 4 ends, but again it's 2 wires. And so the way you would connect it is you would take a wire from the start, let's say the red, and then you would take a wire from the end, which would be the opposite, so it would be the yellow or the gold. And so now suddenly this becomes your center tap. So this middle connection here is your center tap, and then you'd have your start connection and then your end connection. Okay, so this is what is really located on this. So your center tap is really the 2 pins here in the center of the PCB, and then your start of your first wire is here, and then the end of your second wire is here. It'll make more sense once we do the connections. Okay, so now we're here at this point here. Next thing we need to focus on is the feet. So those are the feet. You'll need 6 feet. So we'll have 1, 2, 3, 4. And then we'll do 5 and then 6. So just to make sure it's a sort of like a load bearing, if you like, although it's not very heavy, but we just want to spread the load properly. So I've got the feet here, and I just need some bolts. So I will take maybe, okay, we'll do 20 milli then. So again, I'll fit in here, and I'll need this for 1, 2, 3, just for 3. So I'll just do them now. That's the second one. And the third one. Right. The this one here will need to be much smaller because we'll have to fit it underneath the potentiometer. So the pot here, we'll have to fit it right underneath there. And there's the hole here. You can see there's the hole here. Okay, before I actually assemble this, it probably would be better if I put the transistor on top of this, because it'll just be easier to do it now. And so because there's this cover on top here, I'm gonna need to bend the legs quite high up, around like this. All right, and I'll fit the cover now. Okay, so this is pretty much how it's going to be fitted. So we'll put the feet again. And I'm just going to secure that corner first. Okay. Here we go. Okay, so this one is a little bit more tricky, but it's still doable without having, we can bend this slightly back if it's too difficult to fit in, but I should be able to get away without having to move this. So I mean, for this one, we'll need a smaller bolt. I'll try this one and see what happens. I think that's probably about 16 milli, this one. Okay, that looks fine. Okay, so that looks pretty secure now. And also your switch, you want to make sure it's in the middle position here. It's actually a three-way switch, but we are just really using two positions, the off, which is, okay, so this is the off, and this is the on position, so that's on, and that's off. And this position does nothing, but, right? Okay, I'm gonna add some more feet around, so we've got a flat, stable position here. We'll put in. Okay, so that's all the fitted in, 2, 4, 6. At the back here, there's some room to fit this micro USB. It's a connector, it's a female connector. So I'll just put it in real quick. I'll probably just use the 10 milli screws, those ones. If you decide to use your wall adapter, you'll need a micro USB to connect into this and then into your power wall adapter. And the power ratings is 12 volts, which is required, 12 volt at minimum of 200 milliamps, and you probably just want to have a maximum of 400 milliamps. If you have a 12 volt adapter at 1 amp, you'll need to calculate Ohm's law to figure out your to add a resistor to make sure you're limiting the current into the Lumin lamp. And you'll also need to do the connection. So here on the left it's ground, and then on the right it's the V bus, or the positive. So you'll need your ground connected to the left side of the screw terminal and the positive connected to the right side of your screw terminal. Okay. But for this assembly here, I won't be soldering this, but I'll just be mounting it anyway on here. As for now, I'll just be using the power supply to connect it, or even a battery. Okay, so I'm gonna add the fitting here now. So this is the fitting, but we'll need some wires to connect to the output. So let's get some wires. Okay, so I've got a long wire and then a shorter one. The longer wire is gonna be fitted in here on this pin here. Okay, it feels tight enough. Okay, and then what I'll do is I'll feed it underneath here so it goes on the other side. Okay, and I'm going to do the other one now. Like this. Okay, back in here now. Alright, so the wires goes at the back. There they are. Okay, and I'll need to connect them there, but for now I just need to put the fittings. And I'll put the plastic washer. And a nut. Okay, that's definitely secure now. Okay, so next thing that we need to do is to fit the coil. So for the coil, this coil for example, I need to remove the enamel from the wires so they can make a connection. Okay. So I'll do the connection of the coil before actually mounting the coil, just for ease. So I'll be taking the gold, you can see this is a gold wire. You can see this is a red, so we want the gold wire, which is the start, there. This is the gold. And then the end, we actually want another wire which is red. So this is, I don't know if I can have a bit of a better background here, but yeah, so one wire is gold and the other wire is red. So the start of the gold and the end of the red. And this will be connected channel B start and channel A end on the PCB. So I'll take those. So those two wires will be going channel A end and channel B start, so they'll be connected in there. Okay, and then the other two wires of the coil will be connected. For now it doesn't matter, but all we've got left now is channel A start and we've got left channel B end. So we'll connect one of the wires in there, and if we've got issue with the light not turning on, we'll just swap channel A start with channel B end. We'll swap the wires around, but it should work the first time off. We'll have a look. Looks like some of the enamel insulation's not come off properly. Just and then the last wire, it will go in channel B end. Okay, so now I've connected all four wires to those four screw terminals. I'm just gonna yank on the wire a little bit just to see if they're all solidly connected or loose. Just a little yank test, and it looks fine. And then we're getting near the end now, so here I'll just do a bit of wire management. Okay, and so I'm just going to put, there's a little bolt, which is a 20 milli bolt, M6 20 milli bolt. Again, the component lists are located on hackster.io, and the link is in the description. Okay, so I'm just putting the nuts here. Okay, well that looks solid. I'll try to zoom out a bit. Yeah, so Now it looks finished. I'll just move the wires perhaps out of the way. I don't want them to be sitting on the transistors. This would be the collector side. Okay, and we just need a light bulb and some power. I mean, for the power, I'll just use the power supply for now. So I've got two colored wires, and this red here will be my positive here. I'll need a bit of a longer wire for the negative. Looks fairly solid. All right, so just need a light bulb. So I'll just be using this one for now. Okay. All right, let me try to pull out a bit. Okay. All right, so it's ready to connect and test. In fact, I'll just put a knob on the potentiometer. Okay, here we go. So now it's ready to test. There's the lid of my power supply. Okay. So usually you probably want to start it at 8 volt and at least well, about 400 milliamps. So let's have a look at this. Okay, that's in frame now. There we go. Let's give it a test. So I'm at 8 volt and 360 milliamps. I'll turn the light off. Okay, power is on, and I'll just flick the switch. Okay, here we go. So here, power consumption is 8 volt, 95 milliamp. That is the Lumin Lamp. You can see there's a LED indicator here. So when your system powers on, this LED indicator should always be on. If that LED indicator is not on, there's a problem, a connection issue with your soldering or PCB, or it could be that your transistor's damaged, or it could be that the switch is damaged. So you'll have to test the voltage and see what's going on in there. But always when the system turns on, your LED indicator should be on. And so here I've limited the current to 360 milliamps. You can push it to probably 400 milliamps. Wouldn't try to go more than that because you'll be burning your potentiometer. And it is possible to replace those. You can desolder those and replace them. But I don't actually go any higher than 400 milliamps. And this allows me to test fields and different coils and different efficiencies. For example, I've got this pickup coil. You can see straight away if I put it here or from behind. You can test the field here. I can also put it right next to it and then just change the power and do some tests with the fields. And we can see there's a DC field here. DC field. DC field. And at the center it looks more like an AC field. And that's it. Here's the Lumin lamp.